All right, today we're looking at simple inequalities. In the last two sections, we talked about equations, simple equations and linear equations, and an equation has an equal sign in it. Inequalities, we have an expression that means something is greater than or equal to, less than or equal to. So let's look at the symbols first. When you have this arrow where it's pointed to the left, it means less than. So A with the little symbol B is red. A is less than B. When you have the little arrow pointed to the right, it means greater than. So A is greater than B. The symbol with the little arrow and a little one bar under it means less than or equal to. Okay, so we have A is less than or equal to B. And when you have the greater than symbol with a bar under it, that means greater than or equal to. Okay? Now, a solution of an inequality consists of all values of the variable that satisfy the inequality. Your solution here is going to be an interval, basically. It's going to be an interval. There are going to be many numbers that could probably fit the description here. Okay, many numbers that can fit the description there. So we solve inequalities in a similar fashion that we solve equations, but there's one main difference. Let's look at these properties. The first one says if A, B, and C are real numbers, if A is less than B, then if I add the same number to both sides, then the inequality is preserved. A plus C is less than B plus C. Now these hold true for less than or equal to. The second one says if A is less than B, then A minus C is less than B minus C. Okay? Now, here, the difference comes in with multiplication and division. And it depends on whether we're multiplying by a positive number or a negative number. So if A is less than B and C is a positive number, C is bigger than 0, then A times C is less than B times C. And A over C is less than B over C. So as long as we're multiplying, or dividing both sides by a positive number, the inequality is preserved. However, if A is less than B, and now if C is a negative number, then that changes the direction of the inequality. If A is less than B, then now A times C is greater than B times C. So we go from less than to greater than. And A divided by C is greater than B divided by C. So this last one here is the main difference that we have when we are going from solving equations to solving inequalities. Let's look at some examples. All right, now in solving inequalities, it is you can get the variable x on either side of the inequality that you want. However, the inequality is easiest to read when you get x on the left hand side. And that's what I am going to do today. In doing these problems, I'm going to get x on the left hand side because the inequality is easier to read that way. So here I have x plus 8 is less than 4. I need to get x on the left hand side by itself, so I'm going to subtract 8 from both sides. So x is less than negative 4. This is the solution. X is less than negative 4. Here I have x over 4 is less than 5. Well, I need to get x over here by itself, so I multiply both sides by 4. Now notice, I'm multiplying by a positive 4, which means that this is going to stay less than. Okay? I multiply by a positive 4. Now in number 10, we have negative x is less than or equal to 5. Now, in order for me to get x over here by itself, I need to divide by -1. But when I divide by -1, the direction of this inequality reverses. Now, I say divide by -1, but you could have multiplied by -1. But in either case, the direction of this inequality changes from less than or equal to greater than or equal to. And 5 divided by -1 is -5. Number 12, I need to get that 5x over there by itself. So let me add 3 to both sides. I have 5x is greater than or equal to -10. Now I'm dividing by a positive 5, okay? So my inequality stays greater than or equal to -2. It is only when we are multiplying by a negative number or dividing by a negative number that the sign of the inequality will change. Now, next couple problems, notice that we have x's on both sides of the equation. And again, I said that, the process for solving an inequality is similar to an equation. It's just the thing being different when you multiply or divide by a negative number. So let me go ahead and distribute. 6x plus 30 is less than x plus 10. Okay, go ahead and distribute that 6. Now I'm going to get, as I said, it's easier to get your x's on the left-hand side. So I'm going to get my x's on the left-hand side by subtracting x from both sides. 6x minus x is 5x. I bring down my 30. The x's cancel, and I have it's less than 10. So now let me take this 30 to the other side. I have 5x is less than -20. Now notice we subtracted 30. So the direction of the inequality stays the same. I'm dividing by a positive number. The direction of the inequality stays the same. So x is less than -4. Number 20 is similar. Let's distribute. 3 times 1 is 3. 3 times 2x is -6x. Less than or equal to -4x. Again, I say it's easier to get your x's on the left-hand side. And I left my 1 out. 3 minus 6x is less than or equal to 1 minus 4x. So I am going to add 4x to both sides. So I have 3 -6x plus 4x is minus 2x is greater than or equal to 1. So now I'm going to take my 3 to the other side by subtracting 3. I have -2x is greater than or equal to -2. Now I divide both sides by -2, and when that happens, the direction of the inequality reverses from greater than or equal to less than or equal to. So I have x is less than or equal to positive 1. Alright, so now we're going to look at a couple of problems involving some words. I know that we really don't care for word problems, but we are going to look at a couple of word problems. Let's read what this says. A velometer is designed so that any reading is in error by no more than 1.3 volts. If a measurement indicates 14.2 volts, write an inequality that describes the true value of the voltage of X. Okay? So, what this means is being in error by no more than 1.3 is that, hey, it means that it could be 1.3 more than the value, or 1.3 less than the value. It could go on either side. So we look at this 14.2 volts, and if I subtract 1.3, which is the error, then I'm going to get 12.9. If I take my 14.2 and I add 1.3, I'm going to get 15.5. So what this means is that the lowest value is going to be 12.9 volts. The highest value is going to be 15.5 volts. So I have this inequality, which basically says that X is between 12.9 and 15.5, and it can include both of those values. So 12.9 volts is less than or equal to X, and X is less than or equal to 15.5 volts. Right, the next problem. The rental cost for a machine is $100 for setup plus $14 per hour. So it's $100 for setup plus $4 per hour. So we don't know how many hours, so we let X be the hours, the number of hours. It says how many hours of operation will result in charges that exceed $240. Exceed means that this price that we're paying has to be greater than $240. Exceed means greater than. So we need to solve this inequality. I can subtract 100 from both sides. And then I can divide both sides by 4. X has to be greater than 35 hours. X has to be greater than 35 hours. Let's look at another problem. A student has grades 80, 92, 86, and 78 on 4 tests in a certain course. The final exam in the course will count as 2 test grades. What grade must the student get on the final so that her average, which is the mean, will fall above 80 for the course? So she doesn't want 80, she wants above 80. So we know something's needs to be greater than 80. Now, the mean, the average, her course average needs to be bigger than 80. And here it gives us a hint. The arithmetic mean of several scores is found by adding the scores and divided by the total number of scores. So we have 80 plus 92 plus 86, and we made 78. And then her final will be 2 test grades. So let X be the test grades. Or the final exam grade, I'm sorry. The final exam grade. Now, how many numbers do we have? We have 1, 2, 3, 4, 5. It's 6 really, because this final counts for 2 test grades. So we have the 2 test grades for the final, the 78, the 86, the 92, and the 80. So we really divided by 6, and we can solve this inequality. First of all, when I add up 80, 92, 86, and 78, I should get 336 plus 2x. Now, I need to get rid of this 6, so I need to multiply both sides by 6. 8 times 6 is 48, so 80 times 6 is 480. Then I subtract my 336 from both sides. So 2x is bigger than 144. Divide by 2. X is bigger than 72. So in order for her average to be above 80, her final exam score needs to be above 72. All right. Let's look at number 30. In business, a profit is realized when the revenue or money coming into the business is greater than the cost of operating the business. The weekly cost of manufacturing X computer chips is given by the expression 1500 plus 75X. That's the cost. The revenue from selling these computer chips is given by the algebraic expression 85X minus 3300. What's the minimum number of products must be sold each week in order to produce a profit? So you get a profit when your revenue, which they told us is 85X minus 3300, when your revenue is bigger than the money coming into the business. Or I should say here, the weekly cost of manufacturing these computer chips in this case. So it costs 1500 plus 75X. And we need to solve this. So I'm going to subtract 75X from both sides to get my X's on the left hand side. That's 10X minus 3300 is greater than 1500. In order to get the 10X on both sides, I'm going to add 3300 to both sides. So 10X is greater than 4800. If I divide by 10, X is greater than 480. So you have to sell more than 480 of those chips in order to produce a profit. Right, so this was just an overview of simple inequalities.